Well, I'd like to thank the organizers for inviting me. It's been really great over the last couple of days hearing all the work that's going on at Chalmers and University of Gothenburg, and the government agencies. Wonderful stuff. I want to talk a little bit about what we're thinking of at Carnegie Mellon as a new discipline of societal computing. I'll talk a little bit about the motivation for this and kind of what it consists of. So first I'd like you to consider what I'd call the evolving relationship to computing technology. Now interestingly, on the next slide I have a very old computer. This is actually the third time we've seen this picture during this seminar. Interestingly, history must be really important here for some reason, I guess. But what I'd like you to consider is not the technology itself, the many tons that this thing weighs, that you program it with a screwdriver, all these kinds of things. I'd like you to consider how much impact did this computer have on the lives of people who used it. The ENIAC was used for a number of things. It was used a lot to compute trajectories. It was used sometimes to compute linear regression analysis, those kinds of things. And the impact it had on people's lives was, if you could manage to program it correctly, you could come to the computer, get this one computation from it, and then you go away. The computation is done a little faster than it would have been done by hand. But that's basically the entire impact that it had on people's lives, right? That one computation was about it. Well, this is something newer, something that still belongs in a museum probably. I think it's an IBM AT if I have the model right. It's a big advance over the ENIAC, obviously, but what I want you to think about is how much more of people's work and life kind of moved into the computer. So here you have maybe CAD programs, so you're doing your design work on a computer, there's word processing, you're doing that on a computer. And so now considerably more of your work life, anyhow, is moved into the machine. It's done on the machine, so it's impacting much more of your life. And now, with the advent of networks, email, communication, group applications, now your social life at work has kind of moved into the computer. You're sending email to people, you're sharing documents, putting things into repositories. So this kind of social, at least the work part of your social life, is also done in computers. So much more of your life has now moved into computers. And now we have this. I don't know about this campus, but on my campus, everybody under 25 is usually seen in this position, right? Walking around, walking into things, constantly looking at a computer, doing all sorts of things, texting, talking to friends, sharing photos, listening to music, and on and on. How much of your life has moved into the computer now? Dating, games, I love this, not just for young people, not just for men. And then we have wonderful things like this, team-oriented, collaborative, virtual mass murder, I would call it. Wonderful games like Grand Theft Auto, where you can do drive-by shootings. Fantastic. And then we have from game cars to real cars. This is an autonomous vehicle developed at CMU, which won the DARPA Urban Challenge. It's actually been 10 years ago now. It's hard to imagine it's been that long. And then, of course, as you've seen before, we have about 100 Volvos equipped by Uber running around the streets in Pittsburgh, driving mostly autonomously, but with someone behind the wheel ready to grab it should it not behave properly. And we have upcoming, of course, the Internet of Things, where everything is going to have sensors, everything's going to be connected to the internet. There'll be whatever you do, whatever you touch, whatever you look at, whatever you come near is going to be sensing you. You're going to be interacting with computing technology. So an interesting question, I think, is if you think about human-computer interaction, that used to be the field that looked at how people interacted with computers. You just go up to a computer, it's a different part of your life from anything else you do. It's some special area that needs to be studied. You're interacting with this computer, and how do you design applications, and how do you understand how people interact with computers? Well, what's human-computer interaction now? I mean, it's just life in the 21st century. You're interacting with computers all the time. So, computing technology surrounds us. It makes it possible to do lots of things that we couldn't do even a few years ago. It's great, it's very empowering. But the design and deployment primarily reflects a limited set of concerns. The mechanism, the social or societal mechanism that brings this stuff into the real world is, by and large, for-profit companies, and that reflects a pretty narrow set of concerns. They want to, have an effective business model, and they need to make a profit, and all that's fine and very understandable, but that is kind of a narrow set of concerns. If you think, for example, about social media, what does Facebook care about? Well, Facebook cares about engagement. That's where they make their money, getting people engaged. So they have algorithms, EdgeRank algorithms, they call them, that try to predict what is going to engage you, what's going to keep you there as long as possible, have you interact in as many ways as possible with Facebook, like things, comment on things, because that generates more likes and comments from others. So trying to maximize your engagement. But Facebook has also, and Twitter and Instagram together, have all kind of rewired the way that information flows through the whole society. Most people, in the United States anyway, now get their news primarily from social media, more than other sources. It's the primary source of news. Most people, according to research, don't even know that there are algorithms that are filtering what they're seeing. They think they're just seeing everything that their friends do, whereas, of course, they're seeing a small fraction of that based on this engagement algorithm. And it turns out that what's engaging is things that confirm what you already know and believe, things that you find very comforting, things that confirm your biases. Right? That's what's engaging, by and large. So Facebook and other social media, just by doing good business, have also kind of rewired how people get information. They've sort of changed the whole landscape of information flows in certainly the United States and probably across the world. So it changes us, not just, and this is just one example, social media, all the other technologies we've looked at have a similar impact on society. They change us, not just as individuals, but as a society. And the question I would like to ask is, are these the changes we want? Sometimes yes, maybe sometimes not so much. Are social media helping to contribute to the extreme political polarization that we see around the world? We see it in the US and certainly in Europe as well. Is Twitter partly responsible for the rise of Donald Trump? I think it has something to do with how politics has played out. So these are the fundamental questions that I think a discipline of societal computing should try to answer. How can we design computing technologies to address societal needs and concerns? We haven't really thought too much about that. That's not on companies' radar when they're designing and deploying technologies. And how do we assess and guide the design, implementation, and deployment of new computing technologies as they appear? Technologies make their way into the world very quickly. Can we also try to quickly understand their potential impact and try to guide that in ways that would be better for us as a society? There are lots of disciplines that would play a role in trying to address these kinds of questions. Here are some of them. Obviously, a deep understanding of computer science is important. Also, HCI, participatory design, developed obviously in this part of the world, is also important. The history of how to democratize the workplace and bring people who are going to be using tools into the design of those tools, public policy, ethics. From these ingredients, I would argue we need to forge a new discipline. One of the challenges that this discipline should address is, what are the areas of impact? Where do technologies have impact at a societal level? Right? Not every technology does, but some obviously do. How do we see that? How do we identify that? And how does that impact happen? What are the mechanisms? With social media, I suggested it had to do with the flow of information. For other kinds of new technologies, the impact might be very different, changing traffic flows, for example, making things easy that were very difficult to do before. So what is the deep relationship between society and computing technology? I think we need to strive for a scientific understanding of this. What are the principles by which these relationships happen? So, and what are the research methods that one would use for this? Well, if you're trying to understand societal impact, you probably need a lot of data that's somehow representative of society and what's happening there. You need to apply things like machine learning, statistics, network analysis, game theory to try to analyze the data to kind of see what the impacts are. And qualitative methods are important just to kind of see how the new technologies are experienced by the people who are using them, to make sure that our more quantitative analyses are on target and really capture what's going on. So these are ways of assessing the impact. We also need to work on technology design and deployment, new algorithms, and putting systems out in the world with new technologies or variations on technologies, and see what happens when people start to use them, to expand our sense of what's possible. And finally, suppose we do achieve some consensus about what we would like to see happen at a societal level, and we do kind of understand what the impacts of certain technologies are. How do we take this understanding back into the real world? Because these technologies are generally under the control of for-profit companies. How do we have an impact on them? There's several ways. One important thing is to form research communities, because I think working together, speaking with one voice, or working together on these things, we can have a lot more impact than just individual labs working by themselves. So I think that's very important. And we can collaborate with companies. Often companies are not focused on the societal impact, but they often care and would like to design technologies in a way that would be to society's benefit. And if we could work with them to sort of understand how to make that happen, they're often quite interested in that. You've seen a lot of change, for example, in how some companies handle privacy concerns. And that's kind of as a result of them coming to understand that people think this is very important, and they want people to be happy with their technology and have it being serving the greater good. There's also social entrepreneurship, where you have an enterprise that kind of makes enough revenue to be self-sustaining, but the primary purpose is to do something to change society for the better. If you look at the Ashoka Foundation, that's a network of social entrepreneurs. There's quite a variety of entrepreneurs that they work with. And finally, government policymaking and regulation. One of our faculty members, Lori Craner, recently served as the chief scientist for the Federal Trade Commission in the US, where she was able to impact privacy policies very directly by helping set policy inside one of the leading government agencies. And attention to ethics, of course, that's something that often gets neglected. It was mentioned in some of the earlier talks today, but we need to know, what do we want as a society? What would we like social media, for example, to be doing for us? Where do we want to end up with autonomous vehicles? What do we want them to do for us? We should be thinking about these things and trying to figure out how to bring those to come about. So here are some of the focal areas that folks at CMU are working on. Things like data privacy and security, systems that enhance sustainability, often using machine learning to kind of manage energy use, for example. Smart infrastructure like electrical grid. Policy and legal compliance. Many regulations are embodied in software as the mechanism for enforcement. For example, releasing medical data. It's information systems that kind of handle that task, and so that you have to translate these very mysterious legalese regulations into requirements, precise requirements for a software system. It's a very hard problem. Personalized healthcare and all the data that it generates. And finally, complex socio-technical systems, which is an example I'll give in a little bit more detail. This is my work with my students and postdocs in my lab. Socio-technical ecosystems. Open collections of digital assets. Open source software was probably the earliest example of this, but increasingly it's other kinds of digital assets, 3D printer files, electronics designs, graphical design. There's many collections of these kinds of assets. Many exist in a transparent environment like GitHub. How many people are familiar with GitHub? Okay, I wasn't sure if that was as popular here as it is in the US. It seems that all software in the US lives on GitHub more and more. It's really sort of taken over this space. But there, you have a large collection of digital assets, and the way people mostly develop software now, our students anyway, is to go find frameworks and libraries and kind of wire them together and produce some application that does something very quickly, without even necessarily understanding what's in the libraries and frameworks. You just get something that works and you're happy. That's kind of the way software tends to be developed. And it does create software very quickly, but this overall set of repositories, GitHub alone has now something like 30 million repositories, I think, and somewhere around 12 or 15 million developers are on GitHub. So these repositories are highly interdependent because of all these dependencies, these relationships of one project using the code from another, and yet they're managed independently. So how does all this coordination happen? Here's just an example. Take Twitter Bootstrap Rails, one repository on GitHub, and you look at the package manager and you can figure out what the dependencies are. So these are just some of the dependencies. It depends on ActionPack, exec.js, Rails, Railties. If you look just at ActionPack, it uses these 6 libraries and frameworks. And if you look just at ActionView, it uses these 5. And the graph is actually both wider and deeper than this. It's just an example of the extent of the interdependencies that you see in GitHub. So changes, and the thing about this that I want to point out, I guess, is that if somebody makes a change to Builder, right, clear over on the right, that could break ActionView, which could break ActionPack, which could break Twitter Bootstrap Rails. These we would call breaking changes. They happen frequently. People have done some work to see just how frequent they are in various ecosystems, and they're quite frequent. And they can have shocking consequences. How many people know about LeftPad? I have somebody. LeftPad is one of the weirdest examples. LeftPad is an 11 lines of code, 11 lines of JavaScript, and all it does is put padding on the left. This might be the second program you write in Computer Science 101 or some programming class, right? Very simple program, trivial program. And yet, the person who owned that code had a dispute with NPM over what he was allowed to call his program or something. So he said, in a sort of a huff, he just took his code off, out of the repository. Well, it turns out that unbeknownst to them, thousands and thousands and thousands of websites had a dependency somewhere way down in this graph on LeftPad, including Facebook. Facebook was one of the victims of this. They couldn't build their website for days until they took the references to LeftPad out of, well, they had to figure out where it was referenced all the way down in this graph and take it out and supply another LeftPad program and incorporate that and rebuild their website. But they went for a couple of days not being able to rebuild their website. It's not just little inconsequential websites, it's big commercial ones as well. So we undertook some research to kind of see how do different ecosystems manage these breaking changes that are so kind of threatening and so frequent. And we found that we did a multiple case study published last year. We found that these different ecosystems we looked at, Node.js, the R statistical language, and Eclipse, manage them very, very differently. But one of the things that we found that was so interesting about this was that there's a variety of practices that they bring to bear to manage these changes. And the effect of these various practices is primarily to shift the costs around among different players in an ecosystem. So for example, if I maintain a library and I want to make a change that might break people who are using my library, the easiest thing is just to make the change, right? And all the costs fall downstream on anyone who's using it, possibly anyone who's using their software, and maybe all the way down to end users. That's the easiest thing for me, but I could adopt a practice of, say, writing a migration guide, a little bit of guidance that I send to everyone who's using my code and say, look, if you want to update to my new version, just do these 4 things and then it'll work. So I do some more work, I absorb more of the cost, less cost goes downstream. Or if I'm really nice or really want to maintain my base of users, I could find those projects, make the changes myself, and submit them to them. All they have to do is accept my change and they're up and running again. moves even more cost upstream. So these are just a few of the many practices that we looked at that we discovered that these ecosystems are using at, but they all had this effect of moving costs around in some way among participants in the ecosystem. And I'll come back to this in a second. The other thing we're looking at is the sustainability of an ecosystem. Will it continue to exist? So if we look at this, think of this as either just a single project or as a whole ecosystem. One thing that an ecosystem needs to sustain itself is users. Do I have a user? Do I have a group of users? Do I have a big bunch of users? If the users go away, there's no point to having the ecosystem or the project anymore, and it will obviously eventually die. No one's going to continue to work on it if no one's using it. But you also need developers. You have the old and gray. I don't know if they're all old and gray, but they're leaving. Some are leaving, retiring, moving on to program in other ecosystems, attracted by some new technology. But there's a constant outflow of developers from a project and from an ecosystem. Is that being matched by an inflow of new developers? Is the labor supply stable? Is it growing? Is it shrinking? Another very important factor of sustainability. And finally, are they taking care of the work? Is the throughput of work keeping up with all the bugs that are being found, all the updates that need to be applied, all the new features that they need, and so on? Or are they falling behind? Are there more and more open issues, or are they getting the issues dealt with and closed? So there's at least 3 dimensions to sustainability. And it's most difficult to measure, actually, the number of end users. It's pretty straightforward to check throughput and to look at the inflow and outflow of developers. The number of users is a little harder. But I have a student who's developed ways of doing this using a variety of external data sources. For example, Stack Overflow. I assume if you know about GitHub, you know about Stack Overflow. It's a technical Q&A site used almost always in conjunction with GitHub. But you can just look at how many queries are there about, let's say, JavaScript on Stack Overflow. That's an expression of some interest. If nobody's using it or intending to use it, the number of questions will presumably go down. You can also look at Google Trends and other external sources. Just see if there's evidence out there of interest in this technology. If so, JavaScript looks very healthy here. Right up to November last year, it's an increasing number of questions being posed about it. So it doesn't look like it's losing its user base. There are other projects where the trend is very obviously in the opposite direction, and some you can see the whole life and death by just looking at these kinds of trends. All right, so if we can measure the sustainability of an ecosystem, and we have a number of practices that shift costs around in known ways that we understand, then we hope to have something to do if we see that if an ecosystem seems to be failing. If, for example, the number of users is going down, it could be just because there's something better out there, and this ecosystem is hopeless, but it could also be because this ecosystem has practices which impose costs that are too high on the end users. If we could introduce practices that would shift some of those costs upstream, that might stem the tide of users going away. Similarly, for developers of, you might think of the more infrastructural pieces like frameworks and libraries, if they're not in adequate supply, we could then recommend adopting practices that shift some of the costs away from them. Right now, Eclipse seems to be kind of in that problem. It doesn't have a very good inflow of developers. It seems to be kind of threatened by some of its practices. So our goals, using practices as a lever, something you can move around, something you can shift. You could shift costs among classes of participants to enhance sustainability. We're also working to try to understand the risks of having an open source project in your supply chain. More and more companies are doing this, and as Facebook found out, it can be quite risky. How would you assess the risk? If you wanted to include some projects from GitHub in your product, and it's very hard to resist the temptation to do that. Here's this great software for free, right? If you want to be competitive, you better figure out how to do this well, right? So how do you understand and assess the risks? What's the risk that you're going to get blindsided by a left pad or by some similar kind of thing? So the idea is to develop the ecosystem science that will apply to digital ecosystems more generally by understanding the relationship between dependencies and the pattern of dependencies on the one hand, and kind of the social mechanisms and practices and policies that kind of move costs around and help to manage changes that flow through the ecosystem. We want to develop a deeper understanding of managing bodies of digital assets more generally, which could apply, we hope, to other kinds of assets, but also to software that's maintained in a similar way inside a company. So, takeaways from the talk as a whole. Computing technology kind of mediates our interaction with everything, increasingly. We live in what I would think of as a digital landscape. We need better ways of designing technology for its societal effects. We don't really understand how to do that right now. We don't know what societal impact of something is going to be. And how do you evaluate it? How do we even know what impact autonomous vehicles or social media are having or will have? And finally, we need a research community focused on these kinds of areas to let us steer more consciously towards the kinds of ends and goals that we really want. That's it. Thank you.
Thank you very much. I'll just move over here. Brilliant. I have to ask, at your university, how do you do this when you talk about designing for societal effects? Because we've been talking these 2 days about cross-science, intersections of disciplines. Do you work like that at Carnegie Mellon?
We do. We're very, very interdisciplinary. In fact, I kind of semi-joke. My colleagues, I don't think, would actually see it this way, but I kind of joke that we're kind of incorporating all the rest of the university inside the School of Computer Science. We have a very large School of Computer Science, a couple hundred faculty with a Robotics Institute, and we have HCI Institute, which is kind of psychology and behavioral science, the computational version of that. We have computational linguistics in the form of Language Technology Institute. We actually have a department that's called the Computational Biology Department. So that's kind of how we do it. We've been kind of engulfing other disciplines and pulling a computational version of them inside. I don't know if that's the best model, but that's one we've been following.
Okay, good. Catherine, got a question up there.
Thanks. So I think this is a really interesting presentation, so thank you very much for that. One question I have, however, is that with interdisciplinary research, it can quite often ruin the careers of postdocs.
I'm sorry, could you say that again?
It can quite often ruin the careers of postdocs because they don't end up in a discipline. So do you have any advice about how to handle that? Because we have that same problem in the UK. And then secondly, your comment there about engulfing everything into computing, is that creating a new discipline or is that just taking them over?
Well, let me try to answer the first question first, then I'll ask you to repeat the second one because I didn't quite catch that. So this program has been going for about 13 years now. We've sort of renamed and refocused and finally think we've discovered what we've been up to all along. But we have graduates at Harvard in the statistics department. We have graduates at UC Berkeley. We have graduates at University of California, San Diego, Vanderbilt. Just name all your favorite institutions, and we have PhD students who are there. So placement hasn't been a problem, either in universities or in companies. So what was the second question?
So to follow up on that, do they have a discipline? What's the discipline, or are they interdisciplinary?
Well, they usually have to find a home that's in their home institution somewhere. So at Harvard, it's statistics. We have someone there who's expert on network analysis and statistics that one uses in network analysis. In Berkeley, it's computer science. In Vanderbilt, it's computer science. So it's mostly computer science, but also mostly among schools that take a pretty interdisciplinary view. We've had a few students who've ended up in business schools. But placement hasn't been a problem. There's been a big demand for our graduates, actually.
Thank you. And a short question from Jan and a short answer from Jim.
Okay, I got curious about your last sentences about, it connected to that question too, that you are, so to say, taking over most of the university into computer science. If I put it like
Sorry,
that.
could you say that again? It's really hard to hear up here. Now I realize what you were saying
Yeah.
before.
Okay, so this that you are taking over a lot of things into computer science or computing, do you have an explicit strategy for that? Do you have the leadership with you, or is it just happening?
Yeah, I think it's an explicit strategy. I mean, CMU has always been a place that's considered itself very interdisciplinary. We consider that one of our core competencies, one of our real strengths, is to do interdisciplinary studies very well. And so it just is natural. And we also consider ourselves kind of entrepreneurial, meaning that it's relatively easy to create things. We keep the barrier to creating new things relatively low, deliberately. And so it's relatively easy to create new departments. We don't do it on a whim. We have to make a case that this is going to be a world-class department. But yeah, it's been kind of a strategy to sort of keep things open, keep them interdisciplinary, and to make it relatively easy to create new things, but also to kill off old things if it doesn't work out.
Thank you very much. Give you some chocolate. Thank you.